Hello everyone. In this video we'll talk about portfolio theory and solve a couple of questions from portfolio theory. Let's look into one of the questions. The current share price of Centrica is 96.52 GBX. Over the coming year we have 40% probability that the share price will be 10%, and the rest 40% probability that the share price will be, or the return of that of Centrica will be 12.5%, and 20% probability that share return will be 30%. What we are expected to do is to calculate the return and standard deviation of the returns for the coming years. So we're going to use two formula here. We're going to look into the expected return, which we know WA. I think we have probability here. So this one will be summation of PI, and then we're going to do RI. So just add the probability, multiply probability we return and add them up together. So when we're talking about the standard deviation, we will look into, we'll first look into the variance. So sigma square equal to the variance. And we know the formula for it is just PI, and that RI in here is going to be RP, because we're looking into the probability in here for different state, and minus the expected return, the one that we calculated here, and then we square it. So the difference from the mean return and multiply with the probability, add them up together, we'll get the variance. So if we put, for example, all of this information in here, so just look into what we have. So one of the way, a better way of doing it is to find out all the information, write down all the information that we have. So what do we have here? So we got Centrica's share price. So the Centrica share price is not relevant here. So this price is not relevant, but I'm just writing all this information. So 52 GBX. There's a 40% probability. So P1 equal to 40%. And the share return will be 10%. So on that particular state, R1 will be 10%. And the another 40% chance, which is P2 equal to 40%, the share price will be 12.5%. So R2 equal to 12.5%. And rest 20% probability. So looking into RP3 here, which is 20% probability. And on that, if that particular state happened, the return will become 30%. So these are all information that we have. So we need to calculate this sigma and this expected return and sigma square, or sigma standard deviation. So if we're putting all this information in here, so sum of PI, so we're looking into three different states, P1 R1 plus P2 R2 plus P3 R3. So when we look into the summation, we're just adding them all together. So we got this P1, which is 40%, so 0.40, multiplied by R1, 10%, 0.10, plus P2, 40%, 0.40, multiplied by 12.5%, so 0.125, plus P3, 20%, 0.20, multiplied by 30%, 0.30. So if we do the math, we get 15 0.15, which is 15%. So that's our expected return. Now, when we calculate the variance, we need to take away this 15% for every single return. So we got the sigma square is summation pi. I'm just writing it again so you can remember it. Ri or Rp. So it shouldn't be P, it's actually a different state, right? So Rs, actually you can say Rs. And it's just a denotation, so you can just use the way you want. Expected return, and we are squaring and adding them up, right? So different state, you've got 3 different state here. So S equals to 1, 2, 3. So it's P1 and then it's R1 minus expected return whole square plus P2 R2 minus expected return whole square plus P3 R3 minus expected return whole square. So if we add them up together, just plug all these values. So if we add them up together, after plugging all this value, we get this in the variance, and then we square it to get square root it to get the standard deviation. So the P1 0.40, R1 0.10, and expected return, we calculated it 15%. So 0.15 square 0.125 minus, and then rest 20%, 0.30 minus 0.15 whole square. Now, since we are multiplying, so we're squaring it up, so there shouldn't be a negative value. So all the negative value, we square them up, will become positive value. So if we do all of this calculation, we got 0.00575. So that becomes let's do this squaring it later on. I mean, making up percentage later on. So the sigma is going to be square root of 0.00575, and if we want to square root that one, that becomes 7.58%. In decimal is going to be 0.0758. So just putting this one in percentage. Let's put this one in decimal first. So 0.0758, that becomes 7.58%. So that answered the question of expected return and standard deviation. Now let's look into another question in here. So we have the mean return. We need to calculate mean return and standard deviation, but we have different information in here. We got the 2 different security A and B with a standard deviation of 10.8%, and we got the mean return. We got 2 different mean return. All of them are in percentage, by the way, and we got the covariance. And we are given weights instead. We've got 70% we invest in A, and 30% in B. So we have a portfolio, and we need to calculate the mean return and standard deviation. So the formula that we have is similar to the previous one. So we got the expected return. So we need to calculate the expected return of your portfolio, which is WARA plus WBRB. So we're adding the weights instead of the probability. So let's just find out what do we have here? So we have the mean return. So let's put standard deviation first. It's giving standard deviation first. So we have standard deviation sigma A equal to 10.8%, sigma B equal to 13.1%, RA, return of security A, 4.1%, return of security B, which is 4.8%, and we have the covariance of A and B, which is 0.04. So if we want to calculate this one, let's say, so let's just bring this one in here. So if you want to calculate that one, what do we have? We've got WA, by the way, I forgot to write WA, which is 70%, and WB, which is 30%. And together it has to be 100%. So we've got 0.7 multiplied by RA, which is 0.041, plus WB, which is 0.30, multiplied by RB, which is 0.048. And if we calculate this one, this becomes 0.0431, which is 4.31%. Now, to calculate the standard deviation, we need to calculate the variance first. So the variance, we denote this one with sigma square. We can do this one. The formula is WA square sigma A square plus WB square sigma B square plus 2 WB covariance of A and B. So if this one we have the covariance. But remember, the covariance is the return, the covariance of the return. So you can, if you want, you can also denote this one as covariance of RA, RB. Now put all of this information here together. So it's 0.7, got sigma A square, which is, we got 10.8%, 0.108. Remember, it's square, not the whole square. Sigma B, which is 13.1%. And we write down the covariance 0.04. So when we put this all information, plug them all in together, we get these values 0.0240. So my bad. 0.0241, and this is 2.41%. Now, what I suggest, don't write this variance in here, so percentage in here. So let's do sigma here, which is the square root of 0.0241, and that gives us 0.15524. 524. Put all together in 4 decimal points. I'll tell you why I'm doing 4 decimal. 15.5242%. The reason I'm doing I'm keeping 4 decimal point because of the VaR we need to calculate, and if the portfolio value is 1 million, if we multiply even in a 4 decimal point, that is actually a lot of money. So that is question number BI. We need to calculate the VaR, which is very important in terms of finding out what is the value at risk of that portfolio. So we know this formula already. So the VaR, we're talking about the 95% VaR, is equal to minus mu. Mu is actually the expected return, so we can denote this one as a mu, minus 1.65. So 1.65 is a fixed number for 95%. This value is always 1.65. And we multiply this one with sigma and the portfolio value. So the P is the portfolio value. In our case, this is $1 million. So if we put all of this information here, so we got minus mu, which is 4.31%. Putting this one in a percentage, minus 1.65 multiplied by sigma, which is 15.5242%, and we multiply this one with 1 million. So if I put this one without the million, including the million, that will be, we got 0.213049 million. So putting all the numbers, so and if we multiply this one 1,000, so this will give us 213,049.3. So actually in here there is another 3. So that's the value. So if this is in dollar, so we got this dollar. I'm not sure whether this is in dollar. It doesn't say actually. Oh no, it does say it's in million pound. So this one will be in pound. So this is 213,049.3 pence. This is the value at risk. Now the last question is asking, explain why the actual losses may exceed the figure of VaR 95%, which is 213,000 something, and describe the measure that could be used to overcome this position. So the VaR that we calculated, we assume that that has a normal distribution. So we followed this very symmetrical curve, and then we calculated this normal distribution. We got symmetric in both sides, and we assumed that one. In reality, the assets tends to exhibit fat tail. So it could be fat tail in any of that side. So it could be like that on the right tail. It can be tail on the left hand side as well. So in reality, that could be like that. It's not actually identical to normal distribution. So if it happens, the incidence of the returns at the extremes, normally on the right hand side, this is the extreme values, or if it is negative, these are the extreme values. So this exceed the number of indicated, is actually exceed the number indicated in the normal distribution. And since the VaR considers the value at the extremes, then the actual negative in this case, if it is B, let's say, and this is A, so for the case looking into the negative values, so it tend to actually has more negative than the normal distribution will tell us, or the VaR will tell us. And the expected shortfall is actually measures, which is a correct measure in that case, which has been introduced to take care of these fat tails, either negative or positive. But in VaR, we're looking into the negative side of that. So what we are concerned is how much we can lose. If we are making extra amount of money, that's good for us.